A very, very warm welcome to all of you to the Frege Award colloquium. So every 3 years, the GAP honors a German-speaking philosopher for outstanding achievements in the field of analytic philosophy. And previous award winners were Wolfgang Kühne, Rüdiger Bittner, Wolfgang Spohn, Dieter Birnbacher und Martine Niederrümelin. But this year, another distinguished and internationally renowned philosopher will be honored with the Frege Award, namely Hannes Leitgeb. Okay, so I have to do this.
Jetzt halten?
Ja.
Jetzt geht's.
Okay.
Zurück. Nochmal? Ja.
Very sorry, we have all these technical problems. All right, so this is Hannes. So Hannes is the chair and co-director of the Munich Center for Mathematical Philosophy. And most recently, I think you all know this, he has been awarded the highly prestigious Gottfried Wilhelm Leibniz Prize. But I do not want to go into any further details about Hannes's academic achievements and his CV, because as you can see from the program, now it works, that the colloquium will begin with a laudation of Volker Halbach from the University of Oxford, who will elaborate on Hannes's academic achievements and his curriculum vitae, so I do not want to say anything more about this. As you can see from the program, after the laudation and the award ceremony, Hannes will give a short presentation on some of his current research, followed by 2 commentaries. So the first one by Maria Lasonen, who is not here today in presence, but she will participate online, and I hope she can hear and see us, and Richard Pettigrew from the University of Bristol. After the commentary, Hannes will then have the opportunity to shortly reply to the commentaries, followed by a general discussion until 8:30. So we are very excited to host this colloquium at GAP.12. So Volker, the floor is yours.
Thank you very much. Lieber Hannes, dear guests of the Gesellschaft für analytische Philosophie and dear members. In the academic year 1997-1998, I had a Lehrauftrag at Salzburg, and I was told by my host, Paul Weingartner, well, the students have done basic intro to logic, so don't assume too much when you teach them. They know, maybe predicate calculus. And so I started from scratch, and I talked about some very basic meta-theoretic results in first-order logic. In particular, I explained the completeness theorem for first-order predicate logic. As you know, that's the theorem that every consistent set of formulae has a model. And I also explained that Gödel had proved the theorem in the late 1920s. And one of the students looked really puzzled and then asked, well, how exactly could Gödel have proved this theorem if the notion of a model was defined only in the 1950s by Tarski? Aha, I knew this student had obviously done a little bit more than intro to logic. The student also knew how to get a lecturer into trouble. And I have to say, I mean, I'm still listening to the questions and the remarks. They're good as always. And Hannes's questions can still get me into trouble. So at the time, Hannes was working towards his first PhD, which was in mathematics, although he had already explained to me at that point his ideas for the second PhD. And I think on the picture of Hannes, you have seen there are 2 Ds in the doctor. So he's a double doctor. And back then, we had quite a few conversations and became friends during my year in Hannes's hometown. At the time, we were still young and full of enthusiasm. We developed possible world semantics for modal predicates. That is, we treated necessity and other notions as predicates of sentences. Incidentally, this is what already Rudolf Carnap had done, so no coincidence that Hannes was interested in this. But we got into mathematically deep waters and struggled with the mathematics. And after some time of working together, we became synchronized. So we had worked independently for quite a few, I think even weeks. And then it finally dawned to me that the result we were trying to prove was actually not a result, it was simply wrong. So I picked up the phone and Hannes replied without any further ado, "Oh, you also just realized it." So we had got to the same point more or less in the same minute. Since we were stuck, we decided to ask a specialist in set theory. And the specialist was Philip Welsh. Poor Philip was drawn into our ideas and had to solve our mathematical problems. And later, together with Leon Horsten, who is somewhere here, we founded what we called the Luxemburger Zirkel. At the time, Luxembourg was the geographic center between our universities when Hannes was still based in Salzburg. And we didn't rename our group when the center shifted because Hannes moved to Bristol in 2005. I turned to Hannes's work itself. In an address like this, it's common to say that the recipient of the prize is honored for his contributions to this and that field. And the list of areas Hannes has worked on is really impressive. He has published papers at least in logic and its philosophy, epistemology, philosophy of language, philosophy of science, philosophy of mathematics, metaphysics, the history of analytic philosophy, and the philosophy of cognitive science. However, Hannes's work is not best described by listing all the different areas to which he has contributed, but rather by talking about his method. And of course, his method is mathematical philosophy. Philosophers like to put themselves into a long tradition. Mathematical philosophers can point out that mathematics and philosophy have always had a close connection since Plato and Kant. But mentioning the tradition from Plato to Kant is misleading when describing Hannes's method, because mathematics itself has really changed beyond recognition over the last 2 centuries. Nowadays, if theorizing in some field, and not only the sciences, has reached a certain level of complexity and sophistication, it is often difficult to avoid mathematical methods. In fact, in many cases, these methods are not invented in the mathematics departments, and so perhaps they should be described as formal to avoid the impression that they're just borrowed from mathematics. So a wide variety of formal methods are today found in computer science, linguistics, economics, psychology, medicine, and the natural sciences, of course, among others. So Hannes has used tools from formal logic like set and proof theory, probability theory, informal epistemology, graph theory in the philosophy of mathematics, the theory of neuronal networks, and logic programs for semantics and epistemology. But these are just examples. Hannes's formal methods are diverse and come from different areas of mathematics, so not just the traditional fields of what philosophers know, arithmetic and Euclidean geometry. And some of these tools and theories were invented only fairly recently. in this respect of using these methods, Hannes follows the great founders of analytic philosophy in the Vienna Circle and elsewhere. They realized that with many problems, you cannot get beyond a certain level of sophistication and complexity unless you use formal methods. And of course, these formal philosophers have not only used methods, formal methods, they have shaped them, and in some cases, they have invented them. And modern mathematics has been deeply influenced by analytic philosophers. And many highly abstract areas of mathematical or formal theorizing are places now, I would say, of metaphysical speculation. So the philosopher and mathematician after whom the Frege Prize is named did completely reshape and create mathematical methods and mathematical theorizing, Frege. So Hannes's role model is another philosopher of this kind. It's, of course, Rudolf Carnap. And I mean, he's a role model not only for political reasons, but because Hannes trying to emulate his way of doing formal philosophy. So Hannes also belongs in this tradition of using formal methods in a very creative way. And he has used, adapted, and created formal methods for philosophical purposes, thereby opening new perspectives on philosophical problems, but also putting older theories on firm foundations. It will not surprise you that I emphasize Hannes's contributions to the theory of truth and modal predicates, because this is where my interests are. This has always been a wonderful playground for mathematical philosophy. And I and many others have learned a lot in this area from Hannes, so thank you for this. And Hannes is now perhaps even better known for his work on rationality and probability, but I don't say much about that because we are going to hear an example of this in a few minutes in the following colloquium. And one of his strengths have always been to bring together, different ideas, different technical tools, theory of truth, possible worlds, probabilities, pure logic, the theory of conditionals, and so on. Forgive me for mentioning another topic I'm also interested in. Hannes has not only used mathematics to think about topics in epistemology, the theory of truth, and so on. He has also made mathematics a topic itself and thought about mathematics, as many great philosophers have done. I remember various discussions I had with Hannes, over many, many years, and it's really taken him a long time to come up with the 2 papers on structuralism in the philosophy of mathematics. But I think they are one of the most profound contributions to structuralism in the philosophy of mathematics. But uncharacteristically for him, it has taken him a long, long time to publish them. So Hannes has not only contributed with his research to many areas of analytic philosophy, he is also globally known as the founder of the Munich Center for Mathematical Philosophy. After his time in Bristol in 2009, Hannes accepted a job offer from Munich, rejecting offers from, there's a list of universities, Groningen, Irvine, Stanford, and other places. And he went to Munich as an Alexander von Humboldt professor. This had been made possible by Godehard Link, who had convinced LMU to invest in first analytic philosophy and in particular in Hannes. I think this was really a great achievement that should be mentioned here by Godehard Link. As you know, these Humboldt professorships are highly distinguished positions that allow the holder of this professorship to build up an own research group, and he used his Humboldt professorship to establish the MCMP. And then, after the start, he also expanded the MCMP vastly. And nowadays, there are 2 more chairs at the MCMP, which were added by Hannes, and that's Stefan Hartmann and Christian List. So in this respect, Hannes continued the work of his predecessor, Wolfgang Stegmüller, as the chair of Logic and Philosophy of Science at Munich, by the way, another Austrian. Stegmüller started re-establishing analytic philosophy in Munich from the late 1950s, And in these early days, and still when I was a student in Munich, a lot of analytic philosophy in Germany consisted in bringing the ideas and theories and arguments that were developed in the great centers of analytic philosophy in the US and the UK to the continent. And we always looked to the US and the UK to see what was going on there. But under Hannes's leadership, the MCMP has become one of these great centers. So this is now where people are looking sometimes from the US and the UK. I mean, we do. Nowadays, the MCMP attracts students and researchers from all over the world. I mean, this has become truly international. You don't have to speak Bavarian to work at the MCMP, like in the olden times. And philosophers trained and taught at MCMP have now jobs all over the world. And we owe Hannes for establishing and growing this great center and the boost this has given to analytic philosophy in German-speaking countries and beyond. Of course, Hannes's success hasn't gone unnoticed. There's no time to list all the accolades Hannes has received. I just mention a few. Hannes is also a member of the Leopoldina, which might best be described, at least for the British, as the equivalent of the Royal Society. His papers have repeatedly been selected for the Philosopher's Annual, and today he will be awarded the Frege Prize, and there are hardly any more distinguished prizes for philosophers in the German-speaking world. However, I have to mention something again, what Elke already mentioned. He also got the Leibniz Prize earlier this year. So, and even as a member and strong supporter of GAP, the Leibniz Prize might just outshine the Frege Prize. So it really doesn't get any better in a given year for a philosopher. On a personal note, I would like to thank Hannes for his advice, help, and friendship over the last 28 years, and especially for asking me pertinent questions, even if they get me into trouble, like his first question on the Gödel completeness theorem. So I'm now very pleased to hand over to the presidents of the GAP, who will now formally award the prize. Hannes, my heartfelt congratulations on winning the Frege Prize.
There's the firework. Would you please come up on the stage, Hannes? Yeah. Yeah. Congratulations. Yes, please. Can't read it because I think people won't hear me. But yeah, it just says, mit seinem philosophischen Werk hat sich Professor Dr. Hannes Leitgeb um die analytische Philosophie verdient gemacht. Düsseldorf, den 10. September 2025, das Präsidium der GAP. Herzlichen Glückwunsch.
Vielen Dank. Vielen Dank, Markus. Vielen Dank. Danke. Danke. Danke.
floor is yours.
Good. All right, can you hear me fine? Everything works? So this feels a bit like the Oscar ceremony, where people are saying, I haven't prepared anything, and then they have this long list of names. Right? But it won't be like that, but I need to thank you, of course. Thanks so much, I feel so honored. Thanks so much to the GAP, to Elke and Markus in particular. Such an honor. Thanks so much, Volker, for your very, very kind words and your friendship. It's cheesy, and I will only say it once and then never again, but without your support early on, it would not have been possible. That's a fact. And I want to thank to many other people. I'll just select a couple of them. I need to thank my supervisors back then from Salzburg days of my 2 PhD theses and my master thesis. One is here, Gerhard Schurz. Thanks so much, Gerhard. Hans Schermack and Bernhard Mitterauer. Hans Schermack is no longer with us, unfortunately. Then my colleagues back then and colleagues now in Salzburg, in Bristol, including Richard. And in Munich, of course, Godehard Link was rightly mentioned, and there are many others. It's a wonderful place to do philosophy. I need to thank my students. They keep me honest, and they keep us honest, so that's very important. The whole community, the whole philosophy community in Germany. To give you an example, I'm going to talk about a paper very soon, and if I look in the audience, there's many people who helped me already with that paper, like Wolfgang Spohn and Hans Rott on the formal side, and on the reason side, Benjamin Kiesewetter and Singer Behrens, and at home in Munich, Alessandra Marra, and so on. And that's the kind of spirit that I benefited from over the years so much. I should also thank my wife, but she's not into philosophy at all, so I won't. And I know she's fine with that, trust me. And I also take this award as a little piece of evidence that logic broadly understood is alive and kicking in philosophy, which is great to hear, especially in times that are all too often quite irrational today. So thanks so much again. Thank you. Right, but now let's do some philosophy, right? Enough with that. There's a new paper that I'm currently working on. It's about epistemic reasons. And if things go well, it might serve as another nice example, hopefully, of mathematical philosophy, the application of mathematical methods to philosophical problems and questions. And the idea of the paper is to bridge two fields that seem to be a bit isolated from each other, and some people are interested in changing that, and I'm one of them. The one field is the philosophy of reasons. As we all know, reasons have become a very big topic in recent decades, especially in practical philosophy, reasons for action, but also in a part of epistemology, normative reasons for belief. And that's what got me interested recently, and I sort of caught fire. There's a lot of wonderful philosophical work there. So in this area, people are, amongst others, interested in what's called normative pro tanto reasons for belief. Okay? So these are facts that speak with some strength for or against believing propositions. And that will be my topic. Okay? So they are pro tanto in the sense that they are not necessarily sufficient or conclusive or deductive, but what they do rather is to speak a little bit for a proposition, that is, believing in the truth of the proposition. And then there's another fact that's a reason that also speaks a little bit for it. And then you put these reasons together, right? You aggregate them, and then hopefully, when things go well, their strengths will add up, right? And then they might become, sufficient and so on, right? But these are the reasons that I'm interested in, and in this kind of phenomenon of adding up, if there is such, because as always in philosophy, this is controversial. Okay? Now, the other field is formal epistemology, and you might think, why bring up formal epistemology? Well, there are problems, as always in philosophy, and one is that people worry about maybe the lack of rigor, right? So I was describing sort of a picture, right? There's this picture, the kind of weighing picture or force picture of reasons. But if you don't say more, this sounds a lot like a metaphor, but it might, reduce to a metaphor, okay? And there is this kind of worry, and it has been nicely voiced by Jeff Horty, one of the people who work on the logic of reasons. And as he says, once we move past the level of a rough outline, it will not do to say only that reasons lend some kind of weight to conclusions, and that these weights are assembled somehow. That's the aggregation. A theory of the relation between reasons and their outcomes should be subject to the same standards of rigor that Frege brought to the study of the relation between premises and their consequences, logic, right? So rigor, right? In order to make the theory of epistemic reasons more rigorous, right, it seems to me useful to use methods that have been employed successfully in formal epistemology. That's why I suggest to build that kind of bridge, okay? And I also thought it's fitting, right, since Frege is here mentioned, it's the Frege Award, right, so. All right, so that's the other area, and that's an area that I've been working on for quite some time. There's different ways of doing epistemology formally, but the kind of default way these days is the Bayesian way, right? Subjective probability theory, as people say. And that's the area, as you know, where we are not so much interested in categorical belief, but rather rational graded belief, rational degrees of belief, right? And there are arguments that these rational graded beliefs need to be governed by the axioms of probability, right? So if you give a proposition A a graded belief of, say, 0.6, 60%, right? Then you would give its negation sort of the rest, right? That's 0.4, 40%, and the like, okay? And then there's rational reconstructions of update, of learning methods for, perfectly rational agents. Those are the agents that I will be interested in now, like conditionalization, right? You get a piece of evidence, and after the update, it gets probability 1, you're certain of it. And there are more realistic sort of versions of update, where after the update, maybe some proposition gets a high degree of belief, 0.9, but not necessarily 1, and the like. And there are notions of probabilistic support, right? And support already sounds a lot like reason for, and that's not a random coincidence, right? And I'm, of course, not the first one to observe that. I look at Wolfgang Spohn here, right? He has a different approach to his ranking functions, but that was also the guiding thought for his theory of reasons. So there is bits and pieces that would build a bridge, but I think it's fair to say that mostly these fields work in isolation from each other, and if I'm right, we want to change that because both sides can benefit from the bridge. And the bridge, in my case, will be built by an axiomatic theory. Okay, so, that's what I think philosophically when I think of Volker, axiomatic theories of truth, right? Here it's not axiomatic theories of truth, it's axiomatic theories of the reason for relation, okay? As you're going to see very soon. I should say that, like when you build a real bridge, right? So this also comes with some downsides, right? Maybe you have to cut some trees and so on, okay? So both sides will have to have some tolerance, okay, with respect to the other side to make this work. And I can remember I gave a talk about this not that long ago, and then someone in the audience told me later, yeah, Hannes, nice idea, but it won't fly, okay? Because, no, there won't be this tolerance, okay? Also, the sort of the sociology of the two camps are sort of too different. And so, I'm more the optimistic person. So let's see how it goes. I won't give up that easily. Okay. So for example, at the end you will have you will see an axiom where I speak of revising one's belief function, that's a subjective probability measure, by a reason, and that's a way of talking that you won't find in either of the two fields. Okay. So on the reason side, people are happy to say reasons support or justify beliefs, but they hardly say that beliefs get revised by reasons. Okay. So that's the price that I mean. And on the Bayesian side, the formal epistemology side, right, they are happy to talk about revision and update all the time, these Bayesians, okay, but not by reasons, right? So, there will have to be some tolerance from their side too, and so on, okay? But then again, if you get into this literature, there's a nice talk by Jonathan Dancy from last year on the metaphysics of reasons, so that's coming from the reason side. And when he then explains epistemic reasons, he says, reasons for believing that P are facts that raise the probability that P. So, people are well aware that there should be a bridge. He doesn't do anything with that thought in his talk then, but I think something can be done, okay? It's not unheard of. I also want to leave open whether one side of the two is prior to the other, okay? So as you can imagine, right, there are reasons philosophers who think that maybe we are able to reduce everything maybe in epistemology to reasons, right? And then there are radical Bayesians on the right-hand side. They might think everything can be reduced to subjective probabilities ultimately, right? Maybe Richard does, I'm not so sure, but it could be, okay? So, I will leave that open, okay? I just suspend judgment on that. I'm from Austria, we're neutral, okay? For me, the bridge is more interesting, okay? How would the two sides fit together for perfectly rational agents? That's what I'm interested in, okay? And then the theory would be open, in principle, to add some, say, metaphysical reduction claims by which one side would get reduced to the other, okay? But it's not part of my theory. All right, so that's the picture that we want to rationally reconstruct in a sense, right? So we have a fact, that's the little x. We have propositions like the A and the not A here. And we have a strength, okay? That will be the little r. And the picture, the metaphor is the weighing, right? By a scale, okay? By a balance, okay? But what you put into the pens here is not physical objects, but the facts. So the little x will be a fact, okay? Now, what are facts? I can't say too much about it, but it's important for me that facts have a kind of mereological structure, okay? So it makes sense to say for me that one fact is part of another fact, okay? Or that two facts overlap, that means they have a non-trivial joint part, okay? Or that you can bunch together facts, you take their mereological sum, okay? So there's a little bit of metaphysics of facts that I'm going to need and presuppose in my theory, okay? Then there are propositions like the A and the not A here. There, I take the view that it's most congenial to a probabilistic side, according to which propositions are sets of possible worlds, sort of the intentional semantics picture, okay? And then the little r here, the strength of a reason, that will be a real number, right? So some positive number that's sort of being for, right? Some negative number that's being against in a sense, and the zero that's sort of in between, okay? And of course, all of these things need arguments. So for example, why can we measure strengths of reasons in terms of real numbers? This needs an argument. Ultimately, there needs to be a measurement theory for the reason for relation, okay? And I've worked already a little bit, and I think this will work, okay? But that's not the paper that I'm presenting today, okay? It's like with probabilities, right? Also, probabilities can be expressed sort of in purely qualitative or comparative terms, okay? And then you show that, certain assumptions being satisfied, you can measure probabilities also by numbers. And that's the thing that I'm already presupposing here. In a future version of the theory, you might actually start with a relation like X speaks for A more strongly than Y speaks for B or the like, okay? But that won't be my topic today. And now, if they are in a configuration like this, right, I will say they stand in a certain kind of reason for relation, which I denote, or rather I do not, because I need to click there. Sorry. Yes. That's this relation here, the R relation, that holds between an X, that's a fact, A, a proposition, and the little r, that's a real number. And I'm going to read that as X is a reason of strength R for proposition A, and it's always meant for believing propositions A. That's the only thing that I'm interested in, right? It's not about practical reasons here. Okay? This R will be a primitive, so every chain of definitions needs to bottom out, right? And in a theory of reason, it should be natural enough to start with the reason for relation as a primitive, okay? So I will have axioms for it, but I won't explicitly define it, okay? I should say, really, there are some tacit parameters that I'm hiding, as it's usually done in the reasons literature, unless we want to philosophize particularly about them, okay? And one of them is the context, because in the meantime, in the theory of reasons, it's acknowledged that reason strengths are really relative to context. When the context shifts, reason strengths might shift as well, okay? I guess we're going to return to that in the Q&A, but here I leave it sort of tacit, okay? And then there will be a second reason relation. The first one I call direct reason relation. That's sort of the epistemic force that's exerted just by the fact by itself, okay? And if that fact doesn't say anything about another proposition, say A or B, right, then the X will not stand in the R relation to A or B with respect to any number, okay? So that's possible, okay? So there are gaps, as it were, right? But with the second relation, which I call the doxastic reason relation, that's the S here, that won't be so except for, tautological propositions or contradictory propositions, okay? They will, extreme cases that we are going to leave out. Now, this second doxastic reason relation, I read like this: X is a reason of strength little s, another number for believing proposition X, relative to a belief function. Okay? And these belief functions are these subjective probability measures. And now you can see we enter Bayesian territory. That's the Bayesian territory. That's the one that's closer to Richard. That's the reason side. Okay? Now, why do that? And what's the rationale for going there? Okay? So look at this picture up there. There you have the reason, and it speaks for A with a certain strength. That's the little r. Okay? And that might be it. Okay? With respect to the A. But then, both A and other propositions like A or B, they are in the space of propositions on which your subjective probabilities will be defined, right? You have degrees of belief in them. And this can be thought of in the way that between the A and, for example, A or B, it could be any old proposition, capital X, right? There are inferential links, right? So, for example, if A is true, then A or B must be true, right? Or the conditional probability of A or B given A is 1 and the like. Okay? So they are all sort of tied to each other, all the two propositions, right? They are tied to each other inferentially through the agent's degree of belief function. Okay? They hang together. It's like there is a bit of a string, a logical kind of string, okay, that holds between the A and the A or B. And my picture is now the fact X, okay, imposes some epistemic force on A, right? Roughly, intuitively, it pushes and pulls the degree of belief of A around, okay? That's just what the fact does by itself. But because the A is inferentially tied to A or B, there's some kind of indirect push that also A or B receives through X in that way. But it's mediated through the agent's degree of belief function. Okay? So that's why this second relation has another argument placed that the first one lacks, and that's the B, okay, the subjective probability measure, the belief function. Okay? The advantage of the S relation will be that once you fix the fact little x, okay, and you fix the agent's degree of belief function, then for every capital X, every proposition other than the extreme ones, there will be actually a unique such little number S such that they stand in the S relation. Okay? So you can say, X speaks for this proposition, this proposition, this proposition with their different numbers. Okay? That's not what we had with the R relation. The benefit and the advantage of the R relation is that it's independent of the subject's degrees of belief. Okay? It's just about sort of the facts qua reasons themselves. Okay? And you will see there will be a part of my theory that is just about R and is sort of autonomous with respect to Bayesianism. And that's nice. The Bayesians might not like that, but the reasons people hopefully will. Okay? But then once you make the step to S, you need to invoke the probabilities, and that's fair enough, I think. Okay? You might think it's a bit of a downside that all of a sudden we have two reason for relations, where initially we might have thought we just have one, okay? The one that we express in natural language when we say something is a reason for and so on. But that's not the way I see it, right? Once you make things more precise and you try to clarify them and systematize them, it can be that something that intuitively looked like one relation turns out to be the superposition of two relations that you now can tell apart with your more fine-grained means. And I think that's what's going on here, okay? And in fact, you can show in the theory that, the R relation gets sort of extended by the S relation. Whatever stands in the R relation will also stand in the S relation, okay? But the S relation extends R to other propositions, right? Where the fact by itself would not tell you anything, but the fact together with the belief function does. So a way to think about R and S is that sort of R is sort of an invariant pattern in the S relation that's invariant under changing around an agent's degree of belief function, okay? And now, what we are going to do is we are going to impose axioms, okay, for the R relation, and then later we are going to define explicitly the S relation, because the S relation is not a primitive, it's explicitly defined. Okay? Here's an axiom. For R, there are other axioms, okay? They are in my paper. The commentators know about all of them, but I'll give you the gist if I can, okay? And I'm really grateful to the commentators here, because also to Maria, of course, because it's a long paper, so this was hard work, so thanks so much. This is an axiom that I call the axiom of right strength, and it says, if little x speaks for y with a strength little r, and x logically entails y, that's the subset thing, x is a subset of y, and x is non-contradictory, okay, then the little x also speaks for the stronger proposition with the degree r. Okay? Sort of, reason strengths get inherited downwards towards the more specific, as it were, right? in case you've been to Thomas Schmidt's talk yesterday, which was about a similar topic, he has a downwards principle and an upwards principle. I lack the upwards principle. I don't have that because I think you get into trouble if you have both, okay? But, Thomas and I are still discussing that, okay? Now, how do you justify that axiom, okay? It's hard to justify just by itself, okay? But I think there's a justification for it within the theory as a whole, okay? And I'm going to return to it. But it's related to Hempel's converse consequence condition, if you remember old stuff about confirmation. And it's a bit to do with hypothetical deductivism, right? If some piece of evidence concerns a theory and you have a stronger theory, right? Sort of the stronger theory inherits something of the confirmation of the weaker one, okay? So it's not unheard of, okay? For the second principle that I want to give you, it's good to look at this picture. Here we put several physical objects, as it were, into the pan, right? And then their weights add up. That's the idea, at least, okay? Now we are going to do the same, but remember what we put into the pans are facts, okay? Now with physical objects, look at the left-hand side, the little x and the little y, right? They are not going to overlap these physical objects, right? By physics, as it were. But in the case that we are considering, we have facts, they might overlap. They might share parts. And then if you weigh them, right? And if you try to add up the weights, as it were, there might be some double counting going on, right? If you count something that's sort of in the one fact and also in the other, right? So you need to make sure that this is not the case, and that's why I will have a non-overlap condition, a mereological non-overlap condition for the facts, okay? And then, the picture is also a bit too simple. Here, x and y, they speak for A, for the same proposition. But it could be that x speaks for A and y speaks for B. So what do you do then, right? A different proposition. So here's the axiom. So first of all, if you have two facts, x and y, their aggregation is just their mereological fusion. You put them together, okay? Then you get the aggregated fact. And now the question is, how strongly does this aggregated fact speak for a proposition? And with, what's the number, as it were, right? And that's the axiom that tells you that for non-overlapping little x and little y, as promised, okay? And that's quite a mouthful, but if you just look at the right to left side of this if and only if claim, you will find that you have the two facts, little x and little y. X speaks for A with a strength R, y speaks for B with a strength little s, okay? And now you take the intersection, okay, of A and B. By the previous axiom, X is not only going to speak for A with the strength R, but also for its subset, okay? A intersected with B because of this downwards principle, okay? And Y is not only going to speak for B with the strength S, but also for its subset, namely A intersected by B, okay? So X speaks for A and B, as it were, with a number, and Y speaks for A and B with a number. And now you put together the facts. What happens to the numbers? And the answer is they add up. And literally they add up. That's a sum, okay? That's basically what's going on in this axiom, okay? And again, how do you justify that? Well, it's tricky to justify it by itself, but within the theory as a whole, with its Bayesian components, I think there is a very good Bayesian justification for this axiom and also for the previous one, okay? That's sort of the justificatory strategy that I'm using, okay? Here is, in terms of a picture, what happens, okay? You have the little x and say it speaks for A with a strength of 3 and with sort of 4, that is against really, not A with a strength of -3, okay? And then you have Y, 4B, 1, 4 not B, -1, right? So this is just a depiction of what the R relation would tell you, right? R holds between X and A and the number 3, for example, and so on, okay? And now you aggregate them, you put them together, then their mereological sum, says the axiom, will speak in the way depicted here. It's going to speak for A intersected with B by a strength of 3 that comes from the A and 1 that comes for the B, right? Sort of, you get a quarter of logical space that's supported from X and from the Y side, and the numbers add up, and 3 plus 1 is 4. That's why you get a 4 in that quarter, okay? And if you add up the numbers for the other suitable quarters, you get the other numbers. That's basically what's going to happen in that axiom, okay? The little squares here in the picture, the tiny ones, think of them as like possible worlds. So every possible world gets its share, right? If it's in there, it also gets a 3. If it's in a quarter where there is a -1, it gets a -1, and so on, okay? So you can also think of it in the way that what the R relation tells you is what the epistemic forces are, as it were, of these facts, okay? They are numbers for each world, and thereby you get a longish vector, right? If you only sort of denote the quarters, you get a 3 and a 3 and a -3 and a -3, that's the x. You get a 1 minus 1, 1 minus 1, that's the y, right? But now, put into the quarters. And then if you take the force of the aggregation, that's just the sum of the forces. So it's like in physics. In physics, physical forces push things around in physical space. And here these epistemic forces push things around in logical space, as it were. Okay? So that's the metaphor now made precise. Okay? And now the final axiom that I want to explain is the axiom of belief revision. As I mentioned it, there is a more general version, but let's look again at these simple reasons that speak for a proposition with a number, and then for the complement, for the negation with minus of that number. Okay? And now what's going to happen is the following. Okay? Reason strengths show up in changes of odds. Okay? That's the credo of this axiom. So let me explain that. Okay? So if you do some betting, if you're from England, you will. Okay? You know what I mean by the odds, right? It's the probability of a proposition like the B of A here, and over the probability of its negation, not A. Okay? That's the ratio. Okay? So it could be 1 to 1, right? Then both probabilities are 1/2, right? It could be 2 to 1, right? Then the probability of A will be greater. Okay? That's the old probabilities of the agent, says the axiom. Okay? And now the axiom says, what happens when you update by a reason, little x, that becomes accessible to the subject? Okay? And for that, I have a function, b revised by x, the revision of the belief function b, the probability measure, by the reason x. And that's then the new degrees of belief that the agent is going to have after the revision. Okay? That's the left-hand side. And you get an odds there too, the new odds, right? That's b revised by x of a over b revised by x of not a. That's the new odds after the update, okay? And what the reason strength does, x speaking, remember, for a with r and for not a with minus r, is it tells you how these odds change across the update, okay? So this is quite a mouthful, looks complicated, but it's not actually, okay? Basically what the axiom tells you is that up to a function, the reason strengths pin down uniquely how the odds are going to change. Okay? And sort of, there's some math here going on, but what's really going on is if you had a reason that would speak sort of with strength 0 for A and with strength 0 for not A, sort of a trivial reason that wouldn't do anything, right? Not an interesting reason. I have it in my theory for simplicity, okay? Then what's going to happen is, with that function thing, the odds wouldn't change because nothing has changed, right? If you get that reason on board, okay? But if the reason strength is positive, so it really speaks for A positively, what's going to happen is that the odds will increase. That is, the probabilities will be shifted towards A after the update. That's what we want, right? A gets more likely. And if the reason strength is a negative number, then with that function in place, okay, the odds will change so that they become smaller. Okay? The function applied to the negative reason strength will be a number less than 1, and the probabilities will shift towards not A. That's what's going to happen. Okay? That's the idea. Or equivalently, right, doing some calculation in the theory, that's something that you then prove in the theory, right? It's a deductive system. The reason strength, that's the R, is really up to a function including the logarithm, a function of the base factor, and that's the new odds over the old odds. You can sort of see how this is to be calculated. And this kind of quantity, the base factor, is something that's really important for Bayesians, okay? So that's the bridge. Reason strengths here on the reason side correspond to, logarithms of base factors on the other side. That's the Bayesian side, okay? That's the bridge. And why that bridge? And then I'm going to conclude. Now, base factors are known in the Bayesian literature to capture, as it were, what's learned by the evidence, the impact of the evidence itself, where the prior probabilities, the old probabilities, the degrees of belief function that the agent has been factored out, washed out, as it were. Okay? So with that quantity, you basically capture what the evidence by itself does, independently of the belief function. Okay? And there's some Bayesian justification for that. And logarithms of base factors, because that's what I have, they have been studied by Bayesians, like H.A. Good, weights of evidence, Hartree-Field. I'll return to that in a sec. Okay? So overall, the Bayesian arguments lend support to the axiom of belief revision because Bayesian update is always in the format of changing the odds. Even conditionalization can be understood as changing the odds. Okay? So I keep that format. That justifies the axiom. Okay? The direct reason for relation does not have the belief function of the agent as a relatum, as I told you. Okay? And the reason is the reason strengths are sort of invariant right? That's this factoring out that we have here, okay? So that's the reason why I can afford myself to not have B as a relatum. And finally, you get a definition of the doxastic reason relation S as promised, and this is just a generalization when you expand to all propositions whatsoever, right? So you have your reason X, you have a belief function that the agent has, you revise the B by the X, okay? With the axioms, you can show this is determined uniquely, and then you determine basically the base factor, take its logarithm, and then you get the number by which the fact X speaks for an arbitrary proposition, capital X. Okay, so this is just generalization. Here the belief function is crucial, it's in the definitions, right? But, and then you get the relationship between R and S as promised. And this S relation has a counterpart, sort of an approximate counterpart in the literature, including Wolfgang's theory, but also Scheim-Neyer's recent theory. So if you're interested, ask me in the Q&A. And the point is, I gave you the additivity axiom for R. R is additive, but S is not necessarily additive. And that's very important, okay? So the conclusion is, I have given you part of a rigorous axiomatization of the additivity of epistemic reasons, okay? I hope, okay? Part of that theory is not probabilistic. That's the part with the R, right? And, aggregation. Part of it is probabilistic. That's the part with the belief revision and the S relationship, okay? There are counterexamples to additivity in the literature, okay? But if you rationally reconstruct them using these resources, what you find is people think that the S relation is additive, but I haven't given you that. So I don't run into these counterexamples, okay? Where the examples of reasons only pertain to R, additivity is fine, right? It's a bit like saying you get additivity for non-derivative reasons, but you do not automatically get additivity for derivative reasons. That's basically R versus S, okay? And you might think, okay, but what is this revision, B star S, X, right? Actually, the update that you get in this way, the update by a reason, is well known in the Bayesian literature, and it has been described by Hartwig Field in the late 1970s as a kind of different version, reparametrization of Jeffrey conditionalization. So you end up with something that's well known and familiar to the Bayesians, and that's really nice. That's what we want, okay? And finally, you might think that's for the geeks, but it's nice, okay? I'm a geek, why not, okay? You can, if you have two facts that are presented to you, X and Y, you can update your degree of belief function by X first, and then by Y. Or you can update by Y first, and then by X. Or you take the two reasons, and you aggregate them, and then you update by the aggregation. And fun fact, this all boils down to the same thing, and you can prove that in the theory. And it seems rational that they should end up in the same place, I think, okay? So, the upshot is the additivity of epistemic reasons is compatible with Bayesianism. One can represent Bayesian update by these resources, so by means of priors and summing up of forces, as it were. That's really interesting, should be interesting even to the Bayesians themselves. And hence, the philosophy of reasons and Bayesian formal epistemology can benefit from joining forces with each other, epistemic forces, as I want to say, okay? And so, last summer I read Philip Kitcher's What's the Use of Philosophy? Not at all, I'm agreeing with all of it, but Philip is still a great guy and a very, very good philosopher. So he worries about both sides. What are these reasons again? Okay, and then what are these formal stuff things for? Right? Of course, in German we would say, nichts wird so heiß gegessen, wie es gekocht wird. Okay, so when Philip visited the MCMP, he really liked the formal stuff, of course, really. Okay, I'm saying it like that. Okay, and then I would say, he's really worried about. You can't just do formal philosophy for its own sake, right? It needs to have a good philosophical purpose. And I hope I've convinced you that there is a good philosophical purpose here. And using these resources, maybe his worries about reasons will vanish themselves. Okay? Thanks so much.
Hi, Maria. Yes, that would be great if we need to switch the audio. And I hope now we can hear you on the loudspeakers in the audience. Let's try that again.
Yes.
Perfect. Yes, excellent.
Fantastic.
Okay, we have your slides on the screen. We can hear you, and I think Malcolm will announce you.
We can't see the whole.
All right, now it's good. Yeah,
So, yeah, Maria, why don't you just start on comments on Hannes? So the floor is yours. We are looking forward to your comment.
all right. Fantastic. It's great to be here, though not in person, but thank you for inviting me to comment on Hannes's paper, The Additivity of Epistemic Reasons. Many congratulations to Hannes for the award. I cannot think of a more deserving recipient. And I think the best way to celebrate is to go straight into philosophy. And what I'm going to do is I'm going to first kind of give you one angle on what I think is exciting about the way in which Hannes is combining the philosophy of reasons and probabilism. And that angle has to do with Jeffrey conditionalization. And then I'm going to focus on what sort of epistemic role reasons could have given this framework, given the axiomatic system. So let me first start by saying a little bit about the reasons, direct reasons relation or direct reason relation that Hannes talked about. I must say I couldn't hear a word of Hannes's talk, but I have read the paper and I could see the slides. So apologies for the terrible picture. It was drawn by ChatGPT, but I just couldn't resist. So Hannes introduces the expression R, which is a primitive in the axiomatic, the formal system. And R expresses an epistemic reason for relation that holds between facts, propositions, and some strength or weight R. So it's a ternary relation. And this notation expresses that X is a reason of strength R for believing proposition A. And what Hannes does is he gives us axioms that this relation is governed by, axioms like the aggregation axiom, and Richard, I believe, is going to talk about another axiom. And this relation captures the way in which facts exert epistemic force on our degrees of belief. So this really is the way in which this reasons talk enters Hannes's framework. And what's interesting about these reasons is these are ternary relations. So these reasons always involve some partition of possible worlds. In the case of an elementary reason, that's a reason for believing some proposition A. The partition is just A, not A. But in the case of non-elementary complex reasons, these are always sort of graded partitions of the set of possible worlds, or at least we can think of the epistemic force of a reason as a graded partition of a set of possible worlds. And this is interesting for various reasons. I mean, one way in which it's interesting is we can't sort of just think of reasons or evidence. Reasons in this case is just facts or propositions. They always involve some partition. And Hannes doesn't say very much in the paper. That's not the topic of the paper about when someone has a reason. But he does allow for things like attention or questions that we're interested to impact the kinds of reasons we have, and hence the partitions invoked. And it's also interesting because then we could have two cases in which a subject in some sense learns the same considerations, but in which the partitions involved are different because their attention is directed to different questions. So that's just an interesting feature of the framework. And there's this connection to probabilism, which is that we think of the epistemic forces as strength or the strengths of reasons as functions of certain odds ratios. So I will say a little bit more about that. So now the connection to Jeffrey conditionalization. I hope that most people are somewhat familiar with some form of conditionalization, some update rules. But what Jeffrey conditionalization does is it gives us a rule for updating our degrees of belief in cases where we learn something. For instance, we have some experience that has some epistemic force, but this learning doesn't involve ruling out any possible worlds. So we don't come to assign a probability 1 to any evidence proposition, which is what so-called Bayesian conditionalization requires. So what happens in a Jeffrey update is we have this set of possible worlds, and a partition of that set becomes salient. And there's a reassignment of probabilities to members of the partition. So that's just something that kind of happens primitively. There's some input partition and a reassignment of probabilities to members of the partition. And then what Jeffrey's rule says is how we reassign probabilities to other propositions in a way that preserves the ratios of probabilities within each partition cell. So what Hannes develops a bridge between his system and Hartree Field's reparameterization of Jeffrey's method. So one thing about Jeffrey conditionalization as such is if we have one sort of partition and an assignment of probabilities of that partition, and then another partition and an assignment of probabilities of that, and we do Jeffrey updates consecutively, those updates, the end result depends on the order in which these partitions are invoked. And so Field showed us how we could sort of abstract these input parameters that represent the impact of evidence or on our degrees of beliefs in the partition propositions. And for instance, in the case of an experience, we could think of the input parameter as what we learn from this experience when we're abstracting away the private probabilities. So the input parameter is in effect a function of ratios of new to old odds of the partition propositions. So it represents what from experience, what learning, what acquiring evidence, what it gives us epistemically abstracted away from the prior probabilities. And these field updates are commutative over input parameters. So if we do one Jeffrey update with one set of input parameters and then another one with another set of parameters, it doesn't matter the order in which we do these updates. It doesn't matter. Okay, so here's what I think is an interesting result and bridge to probabilism. So in effect, if I understood Hannes's view correctly, once we update on the totality of reasons, in accordance with Hannes' axiomatic system, what this amounts to is, in effect, a field reparameterization of a Jeffrey update. So the idea is that an ideal subject has certain reasons or has acquired certain epistemic reasons over a period of time. And what that ideal subject does is they aggregate all of their reasons together. And what this does is we have this aggregate reason, which corresponds again to a weighted partition of possible worlds. And it doesn't matter the order in which these reasons are aggregated, it doesn't matter. We have commutativity. And the partition invoked in this sort of totality, this aggregate complex reason, corresponds to the partition of a Jeffrey field update. And the aggregated reason strengths correspond to Fieldian input parameters. So I think this is a very, very interesting bridge to probabilism. So what seems to be going on here is, one complaint that epistemologists have had with Jeffrey updates is that where the input partitions come from just seem sort of, the update rule as such, of course, doesn't tell us anything about that. And in fact, the update rule is so flexible that you can get from any one probability measure to another probability measure via an update that counts as a Jeffrey update. I mean, you could just go for the maximally fine-grained partition and assign the new probabilities to the members of that partition. So we need some kind of epistemic story of where these input parameters to Jeffrey updates come from, where these partitions come from. And it seems to me that one way of reading what Hannes is doing is he's allowing for a formal framework in which facts about reasons and how our reasons aggregate explain what these input parameters of Jeffrey updates are. Okay, so that's just to explain my take on Hannes's project. And I now want to just raise some questions about it. So one question is, I must say at the very outset that I've personally always been quite skeptical of the usefulness of the notion of an epistemic reason, like picture. I'm skeptical of whether there is anything that could play the role that many epistemologists have assigned to reasons. So one question is, are the kinds of things that epistemologists have wanted to say about reasons, or the kinds of ambitions they've had, are they compatible with the epistemic role of reasons, epistemic role that reasons have in Hannes's axiomatic system? Another question I want to raise is I want to think a little bit about the metaphysics of facts and this notion of overlap. So when Hannes gives us the aggregation axiom, that concerns non-overlapping facts. So we need some background story of when facts do and don't overlap. And we'd also want the background story to be such that it has palatable epistemic results. And I'm going to raise any questions about that. And then finally, probabilism, it seems, has had some trouble modeling certain epistemic phenomena, in particular, the phenomenon of undercutting defeat. And I'm not even going into higher order defeat, but even basic cases of undercutting defeat. And I'm just wondering whether reasons could help, given their role in this framework and given the probabilistic nature of the framework. So this first slide in these questions. This is not any sort of criticism. This is just thinking about the things that epistemologists have wanted to say about reasons, or the epistemologists that give them a central role, and how that stands to Hannes's framework. So one thing that people invoking reasons talk have often assumed is that facts about epistemic justification rationality, some central epistemic status, but those facts are determined solely by facts about the totality of reasons a subject has at a given time, or perhaps has acquired over a period of time. So there's some kind of determining of, for instance, which of my beliefs are justified, or what I have justification to believe, or what probability measure in a more fine framework would be rational. That is determined by these facts about the totality of reasons, and of course, relationships between them, like the relationship of defeat. And in the axiomatic system that Hannes gives us, the degrees of belief of a rational subject depend both on prior probabilities and reasons. So, whether rational degrees of belief depend solely on reasons, Hannes kind of leaves that open, because he doesn't take any stance on whether we could somehow reduce rational priors to facts about reasons. But if we cannot do that, and if we don't want to do that, then this ambition is not going to be fulfilled. Okay, now there's this other idea, and it's a little bit vague and rough and ready, but many epistemologists invoking talk of reasons have assumed a thesis which I call intrinsic epistemic force. And the idea is that an epistemic reason has this kind of epistemic force that it has, and that force depends solely on some intrinsic features of the reason. Now, this is a little bit vague. What do we mean by intrinsic features? But for instance, for philosophers who think that experiences can provide reasons, or perhaps states like seemings, or the proposition that I'm having a certain experience or seeming, they've assumed that the epistemic force of the relevant reason depends on something like the phenomenal character of the relevant experience, or the qualitative character of the experience. And this is something that, for instance, phenomenal conservatives and some dogmatists have assumed, that when I have a certain experience, the kind of epistemic force of that experience depends on nothing but the qualitative character of that experience. Now, I personally think that that's an implausible claim. What seems clear is that Hannes's framework cannot accommodate that, and I think that's a good thing. But we don't actually need to think about intrinsic force or intrinsic features, in terms of anything like character of experience. We could maybe have another view. We could think of it in terms of the propositional content of the relevant reason, or the relevant fact that's involved. And though there's that trivial way in which intrinsic epistemic force holds for this reason thought of in terms of this ternary relation, nevertheless, on Hannes's view, there's no straightforward way of abstracting epistemic force from reasons qua facts alone. And this is probably partly related to the holism of reasons that Hannes talks about, but I just wanted to flag that this is an ambition that many epistemologists who've talked about reasons have had, that you could somehow gauge the force of a reason from the character of an experience or the propositional content of a reason. And this is not something that Hannes wants to accommodate. This is not a criticism, just a comment on how the project kind of relates to epistemic ambitions concerning reasons. Okay, so let me move on to my second set of questions or comments. So Hannes thinks of reasons as facts and assumes that these facts have mereological structure like parthood, fusion, overlap. And when reasons are aggregated, what happens is we take these facts and we have this mereological fusion of these reasons. And the axiom of aggregation concerns non-overlapping facts. So for these non-overlapping facts, reason strengths for intersections of propositional content are added up. So in that case, we can aggregate these strengths. So here, of course, this notion of overlap is important, and we need some kind of background story of when facts do or don't overlap. Overlapping facts have some non-trivial, genuine joint part. And I just wanted to raise a few questions about the consequences of thinking that, the epistemic force of aggregating reasons depends on whether those reasons overlap or not. So here's an example. I learned two propositions. I know that Hannes is not thinking in terms of sort of learning and becoming certain of propositions, but let's say that there are two sort of considerations that become available to me. So first, Lisa said that there will be a storm tonight, okay? And then there's this other consideration that becomes available to me, which is that someone in the sauna said that there will be a storm tonight. Okay, so that there are these two facts. Lisa said that there will be a storm tonight, and that someone in the sauna said that there will be a storm tonight. Now, in fact, given the way the world is, Lisa is the only person in the sauna, okay? But I have no reason to think this. I have no reason to think or suspect that Lisa would be in the sauna. Now, are these two facts overlapping? I actually asked Hannes, and if I understood correctly, Hannes would say that these are overlapping, assuming that Lisa is the only person in the sauna, right? Given that Lisa said that there's a storm tonight and she's the only person in the sauna, the fact that Lisa said this overlaps with the fact that someone in the sauna said it. But now, on the kind of framework we have of how reasons aggregate depends on whether they overlap. And now we have these facts about overlap, which don't take into account the subject's perspective, as it were, in any way. So we could contrast two kinds of cases. One is the case that I just described, in which Lisa is the only person in the sauna, but I have no reason to think so. And another kind of case in which Lisa isn't in the sauna at all. And again, I have no reason to think that she might be. So my, as it were, perspectives, my priors are exactly the same. All the other reasons that I have are the same in these two cases. But I take it that if the overlapping of facts depends on how things in fact are in the world, in this case whether Lisa is in the sauna or not, then the epistemic effects of how these facts aggregate, how they're aggregated by ideal subjects can depend on those facts that also lie outside my perspective. So this is just a question that I wanted to raise. I mean, of course, there are also sort of worries about invoking facts in the first place. Probabilism as such doesn't need to say anything about facts or their overlap, whereas that is something that this framework invokes. But it was more the question I wanted to focus on is this question about, well, if the overlap of facts can depend on things that are not in any way within my perspective, my prior probability function or anything like that, and how reasons aggregate depends on whether facts overlap, then it looks like the epistemic effects of acquiring various reasons can depend on these considerations that are not in any way reflected in my perspective. Hopefully that's clear now. I'm running out of time, so what I'm going to do is actually not give you the full case that I wanted to raise. Probabilism has been criticized on the ground that there are certain kinds of undercutting defeaters that it can't really accommodate. Don't worry, the details of what's on these slides, but for instance, Jonathan Weisberg has argued that because both Bayesian and Jeffrey updates are rigid in the sense that probability is conditional on members of the partition proposition. In the case of Jeffrey updates are always retained. These conditional probabilities can never shift. But there's a certain kind of undermining defeat that cannot be accommodated by Jeffrey or Bayesian conditionalization by either of these formal frameworks. So the question I wanted to raise is that here reasons talk seems more flexible, right? You might think that, if I learn, if I open my eyes and I see a jelly bean and I have an experience as of a red jelly bean, and then I learn that there's trick lighting, we could say that the information about there being trick red lighting undermines the reason or the support provided by my experience for believing that a jelly bean is red, that there's this kind of undermining going on. Whereas it looks like the probabilistic frameworks are less flexible in this respect. And so I guess the general question is that, if there's some ways in which this reasons talk, philosophy of reasons is more flexible in accommodating phenomena like defeat, given that this framework is wedded to probabilism and that in effect, the kinds of updates that we get can be represented as instances of Jeffrey conditionalization. Is this inflexibility provided by the probabilistic framework actually going to be a hindrance? Okay, so I think I'm running out of time. I will stop there. Thank you very much.
So thank you very much, Maria. We now...
Yes, thanks, you did. And there was a huge applause in the audience if you didn't hear it, just in case.
Yes, right, you couldn't hear us. Okay. Yeah, so now we move on to the second commentary.
I thought so.
You thought so? By Richard.
This share. Maria, can you see your own slide saying Maria Lasonen commentary?
I can see that.
Okay, good. Okay, then we are in fact sharing it. Excellent. Wonderful.
Okay, so.
Yeah. And this is back.
Perfect. Thank you very much. Did it work? Going back?
Yeah. It did. Excellent. So the floor is yours.
Thank you very much. Thank you very much. It's an enormous honor to be here. My job, like Maria's, is to do philosophy, which I'll get to one second. But since Hannes said about Volker that he wouldn't be where he is now without the support that Volker gave him, I can say something very similar of Hannes. When I was finishing my PhD in logic, I'd got interested in this paper by Jim Joyce about probabilism. I was kind of puzzled over this area, and I went to Hannes's office. He'd just joined Bristol not long before, and I sort of spelt out this puzzle I had about it and this kind of question about how one might extend it in certain ways. And instead of just sort of talking it through and sort of, mentioning it, Hannes got really engaged in this problem. And we ended up spending a very happy year writing 2 papers together on this. And in the process of that, I think I learned how to do analytic philosophy to the extent that I can do analytic philosophy, and particularly how to do mathematical philosophy. So I think I owe a very great debt to Hannes. So it's a great honor to be here to honor him. Okay, so now let's do some philosophy. So I'm going to zoom out a little bit compared with Maria's comments. I want to talk a little bit about the sort of uses that you can put the sort of mathematical philosophy that Hannes does to. In particular, the piece of mathematical philosophy that he's just presented, but also some of his earlier work as well. So Eric Schließer has recently been talking about this notion of synthetic philosophy. And part of his idea here is that there are certain areas of sort of technical tools in philosophy, such as, say, modal logic or higher order logic, or in particular Bayesianism, where the people that use them have a sort of, you might call it an imperialistic sort of tendency. Schließer uses a somewhat happier term of totalizing, but the general idea is that people who use these frameworks or techniques have a sort of ambition to take over large parts of philosophy and think that that technique or toolbox that they've been working with could be helpfully used by lots of other people. And as a Bayesian, I'm very much prone to that sort of idea. So here is an early statement of something like this in one particular area of philosophy, in epistemology, where Richard Jeffrey, who we met earlier on in his conditionalization rule, is suggesting that this sort of Bayesian or probabilistic approach could really take over the epistemology, which had hitherto been talking about what we now call something like full belief. So Jeffrey says, our ordinary notion of belief is only vestigially present in the notion of degree of belief. I'm inclined to think that Ramsey sucked the marrow out of the ordinary notion and used it to nourish a more adequate view. But maybe there's more there to value. I hope so. Show me. I haven't seen it at all clearly, but might be there for all that. So this is sort of Jeffrey putting forward the suggestion that Bayesianism, this kind of approach to epistemology, and particularly epistemology of uncertain reasoning, might have ambitions to kind of take over the traditional questions of epistemology, and I think is sort of in the background here, can do it more precisely, more rigorously, more perspicuously, and perhaps shed light on questions that are currently in darkness. Now, I think Hannes over the last sort of 15 years has had, I think, 3 projects which could serve someone who had that kind of totalizing, imperialistic, or sort of eliminative approach that someone might have who sort of works in one of these probabilistic areas of philosophy. And this is his probabilistic semantics for counterfactuals, his stability theory of belief, and then this theory of epistemic reasons that we've been hearing about today. Because a natural thought in each of these cases is something like that idea, that kind of intuitive notion that you've got there could better be understood just by jettisoning the notion and replacing it by some sort of probabilistic counterpart. So if you're someone who comes across epistemologists talking about these full beliefs, so you might think, well, surely you just want to say that someone believes a particular proposition just in case they have high enough credence. So beliefs are just some sort of coarse graining of your probabilistic attitudes. And so these probabilistic attitudes can kind of do everything that beliefs can do and more alongside, and so we should just stick with them. Similarly, you might say, Hannes gave an example of someone in the, I think it was Jonathan Dancy, was it, in his talk, who says something similar for reasons, although Dancy, in fact, is a reasons theorist, so he's not thinking about this eliminatively. He says, X is a reason for P. If we're a rational agent to learn X, they would raise their credence in P. And then similarly, you might think something similar is going on in the case of counterfactuals. Here, it's not degrees of belief. It's not probabilities understood subjectively as our credences, but rather probabilities understood objectively as chances. You might think, well, the proposition, if P were the case, then Q would be the case. That's going to be true just in case the objective chance of Q given P is 1 or sufficiently close to 1, which is something like the analysis that Hannes gives of counterfactuals. So as a totalizing imperialistic Bayesian, I have a lot of sympathy with that sort of use of, or that sort of thesis. And as I say, Hannes has had these 3 projects that you might think would feed someone like that, would kind of give them resources for using this, his counterfactual analysis, his stability theory, and his epistemic reasons thing. But what I want to argue is that that would be a very impoverished way of understanding the mathematical tools that Hannes has given us in these 3 kind of major projects. Volker was saying earlier that he thought that Hannes's approach to mathematical structuralism was one of the most profound recent contributions to structuralism. I think the same thing can be said of these three contributions to the different debates that they're part of. What I want to do in the limited time is just focus on two of these projects, the stability theory of belief and the epistemic reasons theory that we've heard about tonight. At the heart of both of these theories is what I'm going to call a bridge theorem. And I kind of think something like this. Hannah sometimes calls them representation theorems, but I think in some sense they're importantly different in a way that I think is much more useful for philosophy. Representation theorems have a kind of long and esteemed career in all sorts of parts of science, social science, and so on, and mathematics. But I think for philosophical purposes, these bridge theorems, even if they don't, say, do more than representation theorems do, they do something different and something, I think, interesting philosophically, something that there's a bit of work to do on the kind of methodology here. So what is a bridge theorem to get us started? So a bridge theorem takes two ingredients. It takes two sorts of items. I'll call them X and Y here. So they might be beliefs on the one hand, credences on the other. Those are the two items in Hannes's stability theory of belief. Or they might be reasons, epistemic reasons of the sort we were talking about tonight on the one side, and credences or subjective probabilities on the other. So it starts off with these two. And I think that's what's importantly different from representation theorems. Representation theorems usually start off with one and then tell you if they satisfy certain axioms, then there's some sort of mathematical construction over here that can do some job of representing them. But for Hannes, both of the items are sort of, at least in the formal stage, equally important, and they both get their axiomatizations. So you get your two different sorts of items, your beliefs and your credences, or your reasons and your credences. You get axioms concerning the first lot, axioms concerning the second lot, and then some bridge principle, typically. And that connects the two things. Hannes talked about his bridge principle in the reasons theory earlier. And then Hannes proves a sort of major theorem. That's usually the centerpiece of these theories. So if the X's satisfy their axioms, the Y satisfy their, and they jointly satisfy the bridge principle, and you get some sort of further conclusion about both of them, importantly. Okay, so I'll just illustrate this with Hannes's stability theory of belief, and then I'm going to talk a little bit about how you might use that theory. Because as I said at the beginning, there's one way of using that, which is kind of an eliminativist way. I'll talk about that. It's my favorite way, but to focus on that is to ignore all sorts of other uses. These are incredibly rich theorems that are provide kind of weapons for people from all sorts of different parts of these debates to use. Okay, so here's the stability theory. I present this largely because it's a little bit simpler in its axiomatizations, but it's incredibly powerful. It's sort of a remarkable theory, really. So you start off with axioms about your credences. They should be probabilities. And then some axioms about your beliefs. They should be consistent. They should be closed under conjunction and single premise entailment. Okay? So those are very, very basic coherence constraints on each side. They're just the standard ones that most people in this literature take. And then you have the Lockean thesis, which is sort of, I think, Foley discovers it in Locke and is kind of standard thing that you want to say if you're in some way an eliminativist about full beliefs. Lockean thesis says there's some threshold T such that you believe P if and only if your credence in P is greater than T. And Hannes shows that if you have these components, if you have the beliefs in one way, that way, and the credences that way, and then they're married by this Lockean thesis, then you get this stronger thesis called the Humean thesis, which says there's some threshold T prime such that if you believe you believe P if and only if your credence in P is what Hannes calls stably high, that is high above threshold T prime, but also stays above threshold T prime, even if you learn other bits of information, as long as those bits of information are things that you don't currently believe to be false. Okay, so it's a kind of remarkable result. It kind of extracts an enormous amount of extra information out of these axioms that we've put on the probabilistic side, on the credence side, and on the belief side by taking the to be this bridge principle that connects the two of them. Okay. Now, how could we use this sort of theorem? Well, turns out that there's a consequence that comes from it. If you sort of look at that idea, and the very notion of stability suggests it, it turns out the beliefs, if they satisfy this, are going to be partition sensitive. So here's an example that I've given in another context. So suppose you believe there's a drink in the kitchen, and you'd like a drink, and so you start to kind of walk over to the kitchen, but as you get towards the kitchen, you start to think a little bit more detail about where in the kitchen it might be. You didn't consider that at all before. So your beliefs were only defined, and your credences were only defined over a rather coarse-grained partition of the different ways the world might be. You didn't think about where in the kitchen it might be. You just thought, is it in the kitchen, or is it in the garage, or is it in the living room, or is it in the bedroom? But now you start to fine-grain things. You start to think a little bit more detail about where it might be in the kitchen. And as you do that, because you've introduced this more fine-grained, your belief suddenly becomes unstable. So where you believed the thing before, according to Hannes's theory, you no longer believe it. It's no longer a stable belief, and therefore, according to this theory, it's no longer a belief. So what can we do with this sort of result? Well, I think what's beautiful about these results and what makes them such a sort of rich contribution to the philosophical debate about this is that they can be used by people from completely opposing sides of this debate. So the eliminativists can use them by saying, well, this partition sensitivity of belief just shows that there can't be any such thing as a belief. Because if there's anything at all in this world that's a belief, it's got to satisfy Hannes's axioms and the bridge principle, and then the credences have also got to satisfy that. But if it does that, then Hannes shows it must be partition sensitive. Surely beliefs aren't partition sensitive, therefore there can't be any such thing as belief. So the eliminativists can use it for their purpose. But so can the non-reductivist, the non-eliminativist reductionist, or the dualist, the person who thinks, no, these two sorts of things do in fact exist, both beliefs and credences. What that person can use it for is to teach them something about what the nature of these things are, if they are going to coexist. So Hannes said something, I think, at the beginning, that when he was talking about the epistemic reasons, that both sides might have to give something. When you're building a bridge, you might actually have to cut down some trees and on either side of it to accommodate it. And that's the sort of thing that people with that sort of view might end up taking from this, that we've learned something about beliefs. It goes against our intuitions, but it's something that we're happy to accept. And then there's another sort of use that you can put these to, and I think this came up in the epistemic reasons case in Maria's comments, is a kind of proof of possibility. I think before Hannes's result, there was a kind of general sense that these two things couldn't really coexist very well. People were even beginning to come up with theories where there was really no connection between the two. You had credences on the one side and you had beliefs on the other side, but there was no kind of natural bridge principles between them. So Lara Bushak has a theory a little bit like that. People were kind of beginning to give up a little bit on the possibility of having a theory that included both. But Hannes's theory gave this kind of proof of possibility. Okay. So that's just to illustrate in some ways the ways that you can use these bridge theorems that Hannes has been introducing in his recent work. So I'll briefly just talk about the work on epistemic reasons, which Hannes has been sharing with us this evening. So again, you've got the same sort of formal setup. You've got axioms concerning epistemic reasons, which are facts. You've got axioms concerning credences, which are defined by propositions. And then you've got some bridge principle, which connects the way that you revise your credences and responses to a reason with the strength with which that reason speaks to different propositions. And then Hannes proves his theorem, which shows a particular further constraint on the connection between these things. How might different people use this result? So again, there's going to be different ways that you can use this formal result. And that is one of the kind of strengths of Hannes's approach to mathematical philosophy, is that these theorems that he's providing us with are kind of useful in all sorts of different ways. So one way are kind of different variations of proof of possibility. So again, there was a kind of sense that it was going to be difficult to provide a precise theory of epistemic reasons that could capture the sense that we have, this idea that people have put forward that reasons are sort of additive in this way, That when you have one reason, you have this other sort of reason, then some ways they kind of add together, and you kind of use this metaphor of the weighing them against each other, which has a sort of additive component built into it. If you have one of these old-fashioned scales, you're kind of placing these different weights onto each side of it. So the thought was something like, well, we might want to continue with the idea of reasons, but we might have to just give up the possibility or the initial intuition that they could be additive. There's these sorts of counterexamples. Hannes mentions one in the paper from Tim Williamson, but there are all sorts of other ones. Another one which I think there's not enough time to go into in detail, but I think in some ways for me is one of the most interesting features of Hannes's result, is that it walks this tightrope between the Bayesian's view on which reasons are really just purely subjective. If you're a kind of radical subjective Bayesian of the kind of old De Finetti sort of variety, then you get to set your priors. And if you take the sort of view that what a reason is just something that kind of raises your probability in it, then you really just get to set whether something's a reason in favor of a proposition or against it, because you've set your prior and to figure out whether it's such that were you to learn it, it would raise the probability in it or not. That's the subjectivist thing, which basically says reasons don't really place any constraints at all on our priors. It's just that we get to fix what effect they will have. And then there's a kind of pure objectivist, which says something like, no, there's really just a kind of a particular strength, such that if you have a particular sort of reason, then you must change, or a particular total set of reasons, then you must change your degrees of belief over to this new function. And Hannes shows that we can find a theory that sits between the two of these, which I think was not at all obvious that could be done, by separating out this R relation and this S relation. Okay, so the R relation gives this kind of objectivity to it. No reasons do, in fact, speak to propositions with a particular objectively determined force. But how that affects your credence function is, what you then end up with after getting that reason is determined by the credence function you had to begin with. And then finally, I'll just mention the eliminativist thing, because as Hannes mentioned, I think Maria mentioned, I was going to talk a little bit about right strengthening. So the eliminativist might, so in the belief case, in the stability theory of belief case, the eliminativist came along and said, look, I agree with all of Hannes's axioms, and I agree with his bridge principle, but I disagree with this conclusion of it. And so what that shows is there really can't be any such things as belief, because if there were, they'd have to be like this, but they're not, and so they can't be. And you might do a similar sort of thing here for epistemic reasons. And Maria mentioned that she's a sort of skeptic about epistemic reasons, and I have some of that skepticism as well. And you might take a similar sort of line. You might take the line, well, look, this is really the best theory we're going to get of the connection between epistemic reasons. This is the best attempt to save epistemic reasons and their connection to probabilities, and yet it has this sort of implausible consequence, which is the right strengthening axiom. So this is the axiom that Hannes mentioned, where it says if a fact speaks in favor of a proposition with a given strength, it also speaks in favor of any consistent proposition that's stronger than P with exactly the same strength. That's the thing that I think is a little implausible. So here's a kind of example you probably think up. Any like this, so suppose Hannes knows that a lottery is taking place and it's got 1 million tickets in it. And I tell him the number of the winning ticket was not 1 million. The fact of my testimony is going to speak with the same strength to the proposition that says that the winning ticket was not 1 million as it speaks to the proposition that the number of the winning ticket was 327. Now, that seems implausible. Okay, that seems like a sort of implausible feature for reasons to have. And so you might end up rejecting the theory on that account. But I think this just highlights a very interesting, given that Hannes has this kind of long-standing interest in Carnap, a very interesting way in which Hannes's approach extends the method of kind of, you might want to call it something like explication or conceptual clarification, but I think of it something more like conceptual excavation or conceptual archaeology, that what you end up doing is instead of just looking at a single concept and then trying to figure out what its consequences are or trying to explicate it or try to make it precise, you look at a concept and its relationship with another concept, and you ask how they're related, and then you draw out conclusions from that. And it turns out, and I think this is what Hannes's theorems show, that you get an awful lot more, or you at least get very new and interesting things by doing that, rather than just looking at the concept in isolation and trying to figure out aspects of that. Anyway, thanks very much.
Thank you. Thank you.
So you know, Hannes, we are running a little bit late. So of course you have the opportunity to respond to the commentaries, but if it's possible, quite.
I'll make it short.
Okay,
Yes.
thanks.
Thanks so much to both of you, Maria and Richard. Oh, fantastic comments, super helpful. I'll start with Maria. Thanks a lot. Back then you helped me a lot already with the stability theory, and now you're helping me with that. Thanks so much. About ambitions, not all the ambitions that epistemologists had with the reasons will become satisfied in my theory, but that's fine with me. That's the little price that you have to pay. So for example, that it should not just be the intrinsic features of a reason that by themselves will do the job. That would run against holism in the literature on reasons. So that you don't get it in my theory, I take even as confirming evidence. So I'm fine with that because it's matching what reason specialists are thinking themselves too. And that justification will not be determined just by the totality of reasons, but in certain cases with the S relation, by the totality of reasons and the belief functions, that's also fine with me. But with respect to R, it will be just the reasons that do the job. And so you get sort of a nice division of what the reasons by themselves can do and what they can only do relative to the belief function. I think that's fine. About the question, when do facts overlap? That's an excellent question. Very recently, I had the pleasure and honor to teach a summer school in Hamburg about the logic of reasons, not mine, mostly by other people. And when I then at the end presented my own theory, that's exactly the question that I asked the truth-maker semantic specialists at Hamburg. And we discussed that a little bit because I asked them sort of for their help. It's a very important, interesting question. I need it in my theory, but it would be good to know more about it metaphysically. I have a little of model of facts that I have in my drawer, as it were. It's not in the paper, by which I could partially answer such questions, I think. But it's a restricted model. So it's a model of facts where I do not have disjunctive facts. And so it would not be good enough, Maria, to answer your question because one of your facts started with someone and so on. So this is like a disjunctive fact, and the model that I have here wouldn't fly. So your question stands, and it's an excellent one. I can also think of facts as true propositions and get the mereological structure for propositions in a coarse-grained manner, one that I do not like, but it's a possibility. And that I can use to answer your question, Maria, and then I think you will be right. Whether facts as propositions, as sets of possible worlds overlap, will be very sensitive to what the basic underlying space of possible worlds is like. It can be an objective space, and it can be a space viewed from the viewpoint of an agent. And depending on what the space is, the answer might then be different, right? Whether two facts overlap or not. And I think that's sort of the intuition that you wanted to capture, and I agree with that. And what's the right space to use, a more objective or subjective one? There might not be a sort of a unique answer. Maybe there's different versions then of the reasons for relation that you get, a more objective and a more subjective one. And finally, the jelly bean example. So to make it short, I can, in my theory, deal with defeaters as facts that work as disablers or attenuators, as people in the reasons literature would say. And I would put those into the reasons part of my theory. So it's nothing to do with probabilities as yet. And I can do that because they are basically copying what they are doing. Okay, so that's fine, I think. The question is then, and that's really the question that you're asking, Maria, what do the features then have to say on the probabilistic side? How do they show up, right, in terms of update? And there are different ways to go. Here's just one. I would say in a normal context, you see something red and the lighting is just normal, no funny business, right? Then this will speak for the object, the jelly bean being red and against being not red and, no funny things going on. But in a trickier case where there's this defeater condition, right? Tricky red lightning, so not lightning, lighting, okay? So you may be tricked into it being red, right? then I think what's happening is, and that is, I think, the effect that it will have on the probabilistic side, the effect of the reason, or the reason itself, will not conform to a simple partition of red, not red, but rather something like a partition in 4 partition cells where you have red and trick lighting, okay? Red and not trick lighting, not red and trick lighting, and not red and not trick lighting. And the reason will give you different numbers for that in that context, okay? So again, reasons are context sensitive, and in different contexts, you'll get different partitions and different numbers, okay? And then you don't run into the problem that I think you're describing, but much more needs to be said about it, and I didn't in the paper. So these are excellent questions. Okay, thanks so much. And Richard, thanks so much. I have very fond memories of us sitting in Bristolian cafes and writing our paper. I hope at some point in the future we'll sit there again and write another paper. That would be so cool. To make it short, no imperialism from my side, okay? The Austrian Habsburg Empire has long gone. It's good. But you're absolutely right about the methodology. It's not so much representation theorems, it's bridge theorems as you describe it. That's really what's guiding me. Absolutely right. And there are different ways of responding to the results that I have. I absolutely agree with that. Let me just say something about the right strengthening axiom, okay? Which I think has better credentials than you might think. That's at least what I want to argue. So we should distinguish between the role that it has in the theory and how much it conforms to everyday talk about reasons, okay? And you hinted at that yourself, I think, at the end. Within my theory, the idea is this, right? If you have a reason that speaks for A, we all agree it should make A more likely, right? But it can only make A more likely if it makes specific ways of being A more likely, right? Because of the additivity of probabilities, right? And the only thing that the axiom suggests is that it makes these different ways of being A more likely in a uniform, in the same way, sort of, right? Now you need to say, what does that mean? And it means, for example, right, if you make A more likely, then previously the odds of A versus not A were 1-to-1, and after the update, right, it's 2-to-1. Right? Now take a particular way of being A, that's a world or a singleton thereof, right? And its odds over not A still, same contrast class, is now say 1/100, right? But after the update, it will be 2/100, right? That's the kind, it's sort of you double, and that's the strength that gets preserved, and that's what I have in mind. So I think from this Bayesian point of view, there's a good sense to it. Now I totally agree, does that uniquely match how we talk sort of more colloquially in terms of reason strength? No. Probably not, right? But it's exactly, as you say, a kind of Carnapian explication or rational reconstruction that I have in mind. The end product should bear some similarity to the pre-theoretic stuff, and I think I've given you some reasons to believe that's the case, but the match won't be perfect, okay? And that might be a case. And I'm fine to bite the bullet, and it's not the first time that this happens, right? If you read Carnap, Logical Foundations of Probability, there's the first edition, there's the second one, preface, where he says, look, I should have made more clear confirmation is a bit ambiguous. Do you mean absolute or incremental confirmation, right? So people just talk evidence confirms hypothesis, but the one and the other should be distinguished, right? So not, where ordinary talk is maybe not precise enough, we might expect some discrepancies with the more formal stuff, and I think that's what's happening here too. Thanks so much.
Okay, thank you. So we have, maybe 15 more minutes. Would that be okay? Just to go a little bit longer for a general discussion. So please raise your hand if you would like to ask Hannes something. Okay, so to Gerhard Schurz, the first one.
Thank you. I was wondering about the inverse direction of right strengthening. So if you assume a proposition which is weaker than Y, say Z, and assume that the fact X is a reason for Z to some degree, then it should also have to be R, right? Because if it would be a value different from R, and X is a stronger proposition, then X would be supported by Q, by the axiom of right strengthening, and Q is different from R. So shouldn't it go also in the weakness direction then, that the strength is preserved by weakening these R?
right? So I hope you can still hear me fine, or should I use that? It's fine?
Okay.
Good. Thanks, Gerhard. Thanks for the question. So I understood you correctly. I had this right strengthening. What about right weakening? Shouldn't we also have that, right? And I don't think so, right? So it would mean if, say, X strengthens A, right? It's a reason for believing in A, right? And now you take a larger proposition than A, right? One that's weaker, right? Then shouldn't it also, strengthen or speak for this larger proposition? And I would say not generally, because if it's a reason for A, right, and it's one of these examples that I had, it could be a different one, but then it's also a reason against not A, right? So if you make A a bit larger, the larger proposition will eat into the non-A area. And in that non-A area, it speaks against that part. And if that gets too big, in a sense, right, you wouldn't expect anymore that it speaks for the larger proposition than A, right? So that's a case where the weighing plays a role, and that's where I would look at the S relation. And with the S relation, it could be that it speaks for A with, a strength of 2, and for the larger proposition with a strength of 1.5 or so. That's fine with S, right? But with the R relation, I think there's nothing general that you can say, right? In particular, you can't say it will speak with the same strength for the larger proposition. That wouldn't work, I think. But it's an excellent question.
Okay, so there was a hand somewhere over there, but yeah. So the next one.
Yeah. Hi. Thanks. Yeah, I had a small question to another long-standing issue in Bayesianism, learning of conditional probabilities, or in recent terms, learning that something is a reason, that effect can be a reason for a certain belief. Do you see that your theory has something new to offer there? Also has to do with overlapping, if you learn that something is overlapping, as in Maria's comment, I would be interested, yeah.
Right.
Yeah.
Thanks, Korea. So I didn't hear the first sentence properly. Higher order probabilities, did you say that?
Conditional probabilities, learning conditional, long-standing.
Yes. Like maybe Judy Benjamin or something like that, yes.
Yeah.
I'm not sure the theory so far has a lot to offer here. I think the theory might be used in the future as sort of a background of a probabilistic or acceptability theory for conditionals, right? And the idea will be that these days many people, Hans Rott, for example, is interested in, you don't accept the conditional if A then B merely because, say, the conditional probability of B given A is high, but also the antecedent, the A part, should be relevant in a suitable sense to the consequent, right? So probabilistically, it should make it more likely, maybe, something like that, right? And this gets close to reasons here. So one idea would be, you determine the acceptability of conditionals, not just by conditional, but you also ask, is what's described by the antecedent, the fact that's described by the antecedent, a reason, a positive reason for the consequent, right? And then you can use the reason relation to get something about acceptability of conditionals, and then maybe you get also something about update on conditionals, and that gets us closer to what you're saying, right? With a more general theory, I think you would have to invoke higher order probabilities. So probabilities that attach to propositions that themselves sort of are to be expressed in terms of probabilistic statements, okay? But so far, my theory has nothing to say about it, but I'd be really curious what it would look like. Thank you.
Are there any further questions? Yeah, Benjamin over there.
Thank you, Hannes. As you know, I'm very sympathetic and excited about the project. I have a question, like a very big picture question about practical reasons. So I think a lot of people in the philosophy of reasons are sympathetic to the idea that there is some kind of unity between epistemic reasons and practical reasons. And I'd just be interested to hear your thoughts about how your project relates to that kind of unity thesis. Do you think there's a tension? Do you think it's entirely compatible with it? Could it even support the unity thesis?
Thanks a lot, Benjamin, and thanks so much again for your help with that kind of thing. I've thought a little bit about it. I'm always very cautious with these things, so big unity, big unifying everything or so. There is a cheap way of getting from where we are here with epistemic reasons to the more practical reasons by looking at reasons for belief in it ought to be the case that A or something like that, right? But ultimately, that's not, I think, what I would advocate. So rather, if you want to have something like that of a pretty uniform, similar structure for practical reasons, what I think is you need a counterpart to the probabilities, and probably this will be values, right? Could be utilities, maybe something of a more general kind. And then just as here positive reasons sort of beef up probabilities, the practical reasons would beef up the values, sort of. And I think that would be the analogy. And if I went to Wolfgang Spohn's talk yesterday, and he does it with his ranking functions, but I think there is a similar thought here. And I think I can do something similarly in my case. But you know, ultimately, I wonder whether it will be a sort of perfect analogy, because the structure of the values in the moral domain, or also maybe in the prudential domain, might be a bit different from the structure of these probabilistic values that we have here. They don't live on the same scale necessarily, as it were, right? If we set up things properly, they might add up. So that's where they are sort of in sync. But there's differences here, right? And in the practical domain, it's like if you commit to an action here, right, you can't simultaneously commit to another action, right? And that's the kind of structure where there's no direct counterpart, I think, on the probabilistic side, right? Where it's really probabilities that attach to worlds or something like that. So ultimately, I think there will also be disanalogies, but that's yet to be developed. The more similarity that we'll get is nice, because the more explanatory power overall the theory will have. But you know, let's avoid this kind of, you know, now we're occupying all of the territory too simply. I don't think that will fly. There will be differences ultimately. Thanks.
Okay, thank you. The next question is to Hans Rott. He's over there.
Thank you very much, Hannes. Great work. You know how much I appreciate it.
Thank you.
You may guess my question even. So you have this objective strength of reasons, yeah? And you briefly hinted at the measurement theory you have in mind. But if I understand you correctly, that's an objective strength of reasons. Can you say anything more about the meaning of the strength, or maybe the measurement of these strengths?
Yes, no, good question. I mean, to be honest, I didn't say it's an objective relationship, right? So I think Richard suggested it might give Bayesianism a more objective part or something like that, right? And you know, the way I've experienced sort of my encounters with the reason philosophy, they want to have something more objective than what the Bayesians would give them, but they're also a bit divided, right? So if you look into the literature, then you find notions like objective reason for and subjective reason for, right? They have something in common, but they still work differently, right? Sometimes it's sort of, you know, just because there's something to drink over there and it's really bad for your body, that's already a reason for not drinking it, right? Even so the agent is not aware of it, right? That's very objective sounding, right? But then, you know, in many cases, in particular in epistemology, we might be more interested in the cases where the facts have become accessible to us, right? And then we get closer to internalist territory. And what I try to do with the theory is to stay as neutral as possible in these respects. So with a little luck, right, using the R and the S relation that I have and some add-ons, you might turn it into an objective reason relation. And now you're explicit about that. And with a little other kinds of add-ons to it, you might turn the same neutral R and S relations into something more subjective. And that's something that in a recent book by Mark Schroeder has been suggested, that there's a kind of neutral or core notion to reason for that's sort of not decided as yet whether it is subjective or objective. And then, you know, you put some flesh on the bones and you can go either way. And that's rather how I think about my theory presently. Thank you.
So there's Stefan Schmidt for the next question.
Yeah, thank you so much for this really, really interesting theory.
Thanks.
I want to understand a little more to what extent we can understand your theory as really giving an explication of our notion of a reason. And I want to ask my question with the example, with a Carnapian toy example. And the Carnapian toy example is the explication, explication that chemistry gives us of the notion of an acid. And as we learn in textbook, usually in everyday life, an acid is something liquid, but after the chemical explication of that notion. Acids are not only liquids; they can only be gases.
Yes.
And then you might still ask, yeah, but why then do we tend in ordinary language not to seem to understand gases as acids? And there seems to be an easy explanation because there are fewer, presumably in our everyday life, acid gases and so on. This explains why in everyday life we tend to understand acids as being liquid. And it seems that we have this kind of error explanation is very important in order to be able to understand this explication as, in fact, an explication of the original notion of an acid. So now let's turn to the reason thing. So your reason star, explicated reason, seems to satisfy this notion of right-hand strengthening. But our ordinary notion doesn't seem, as Andrew's example has shown, doesn't seem to satisfy that notion. So do you have something like an error theory?
Good.
As in the case with the acid case, which explains why in everyday life we don't think that reason, the unexplicated notion of reason, doesn't satisfy right-hand strengthening.
Good. No, that's a good question. No, I don't have an error theory, but it's definitely something that I should think about. Is this still on? Do you hear me fine? Yeah. But let me push back a little bit, okay, and then say a bit more about it. I'm not sure we always need this kind of error theory, right? So, in chemistry, right, they have a good notion of acid, and I don't think it's important for them that they can sort of save the ordinary people's discourse to some extent. To be honest, they couldn't care less, right? And why should the scientists care, right? The scientist notion. So I don't think that's so important, right? Take Tarski on truth. That's for me is a paradigm case instance of an explication in Carnap sense, and he sort of makes that also explicit, right? So you want to stay close, similar to some extent, to natural language discourse, to this concept that we have around for a long time, right? Or even something that we had in the previous theory, previous stage or something, right? That's what Tarski did. He starts with Aristotle, looks at examples and so on, right? But then he says we need to do better, right? And, for example, with the ordinary notion, we might run into paradoxes. We don't want that, right? So let's clean up, systematize, precisify higher order logic and so on. And then we get something that we can guarantee to be consistent, right? And still close enough, we get the instances of the T-scheme, but it's also more fruitful and, all of these kinds of things, right? I can't remember that anything in Tarski that would say, so next section, error theory, right? Why do they mess up like that? Can we explain that? Well, because, they are silly, right? No, that's not in there, right? He wouldn't say so, of course, right? But that's not part of the game. So I'm not sure we should think of Carnapian explications in the way that we always additionally have the burden to explain what went wrong initially, right? We just want to do some conceptual engineering that it's to the benefit of the concept for some purposes. I think that's what's going on, and there's more to be said about it, right? So that's why I'm not so worried in principle, but my example was confirmation, right? That we also think is a very good example of a conceptual explication, right? Scientists saying data confirms hypothesis, right? That's what they talk about. Now we want to explicate it because it's clearly not precise enough, right? And then Carnap observed, well, there's actually different ways of doing that, and to some extent, they are in contradiction with each other, right? And now we could go back to the original notion, and to be honest, I'm pretty sure that scientists' talk about confirmation can be quite contradictory. Right? And I think what's going on is that there are rational patterns, right? Different meanings, but it's all sort of a kind of chaotic thing, even with the scientists, right? And then, call me old-fashioned, but part of this old idea of general philosophy of science was to bring some order here. And if that means you have to introduce two notions, right? And say that's what they meant here, and that's the other one that they meant there, then so be it, okay? And what would explain then the mess? Because they didn't understand that there are different notions there. And here, my temptation, but I have to think about it more properly, it's a good question, is actually, if you look into reason talk, ordinary reason talk, you'll find the same mess. And that's also why some people, I know, some have, said it, they have some kind of, they're not so sure about the reason for terminology. And that might be the sensitivity that it's not so clear that it's always the same thing that we mean, right? And it's not always the same measurement, as it were, that we have, right? So I hope to bring some order into that, forgive me the term, chaos. And, that might then also sort of serve as a kind of explanation. But it's not my primary goal, to be honest. Yeah. Thank you.
Okay, thank you very much. So I'm afraid we have to stop here. So thank you very much, Hannes.
Thanks to you. Thank you. Thank you. Thank you.
Yeah.
Thanks so much.
Yeah.
Thank you.
Yeah, and of course, thanks to Volker, to Maria, to Richard, and of course to all of you to participate in this colloquium in honor of Hannes. So yeah, have a great evening and see you all tomorrow.